So for this section, we want to add or subtract the rational expressions. So we will need to find common denominators and add, just like adding fractions with numbers. So for this first one here, you have a plus 6 over a minus 1 plus 3a plus 5 over a minus 1. So they already have a common denominator. They're both over a minus 1. So you're going to add, just like you add with numbers, you add the numerators together and keep the denominator. So the denominator will be a minus 1, and we'll add a plus 3a gives us 4a, and 6 plus 5 gives us 11. And then for the next one, you have 2 over 3x plus 4 over 6x squared. So these do not have the same denominator, so you can't just add and be done. So you have to make them have the same denominator. Just like if you wanted to add, let's do something simple here, a half plus a fourth. You can turn the 2 into a 4 if you multiply by 2, and if you multiply the bottom by 2, you have to multiply the top by 2. And so that would be 2 times 1 is 2 over 2 times 2 is 4 plus 1/4. And then add the numerators now since they have the common denominator. So you would have a half plus a fourth is 3/4. So same thing when you're adding for rational expressions, when they have variables or monomials or binomials or polynomials or whatever. So look at the numbers first. You have 3 and 6. You can turn the 3 into a 6 if you multiply by 2. So I'll do it with a different color. So times 2. And then you have an x and an x squared. So you can turn the smaller exponent into the bigger exponent. So you can turn x into x squared if you multiply by x. Because then you add the exponents and x, so x times x is x squared. And again, if you do that to the denominator, you have to do that to the numerator. So we have 2 times 2x is 4x over 2x times 3x is 6x squared, plus, we didn't have to do anything to this side because it's already had 6x squared. So plus 4 over 6x squared. Now that they have a common denominator, we can add the numerators. So we'd have 4x plus 4. They're not like terms, so you would just write 4x plus 4 over 6x squared. And I didn't do it on the handwritten notes, but you could actually simplify this because if I take a 4 out of the numerator, I would have left x plus 1 over 6x squared, and 4 over 6 would reduce. So if I take the 2 out, I forgot to get a different color, but that's okay. So you would have 2 times x plus 1 over 3x squared. Or you can write the numerator if you want. You can distribute the 2 and write 2x plus 2. So if you had noticed at the beginning, you could have reduced this. 4 divided by 6, you'd have 2 over 3, and then you wouldn't have had to multiply this side by the 2x. You'd do the x, and it would already be reduced. So on the handwritten notes, I just left this answer. I wouldn't really dock you any points if you didn't simplify, because the bigger, more important thing is, can you get the common denominator and actually add? Usually for mine, they don't, it's not something that could be reduced to start with, so you have no choice, and then it usually can't be reduced at the end. But anyways, you could reduce this one further just to make it simplified more, but the more important question is, can you find the right common denominator and go from there? So for the next one, you have x plus 2 over x minus 5 plus x minus 1 over x plus 2. So make sure you pay attention. It's a plus, not a times. You can't cancel these out or anything. So again, you need a common denominator. So you have an x minus 5 and you have an x plus 2. So just like if you had me go back up here. Let's do 1/4 plus a 5th. To do a 4th plus a 5th, to get the common denominator, you can turn 4 into 20 and turn 5 into 20. So you multiply this side by 5 and this side by 4 on the top and bottom. So that it turns into 5/20 plus 4/20. So the same idea, you just, to figure out the common denominator, we multiplied 4 and 5. So same thing here for your common denominator. You would just do x minus 5 times x plus 2. Because there's no way to turn them into each other, so you just have to multiply them together. So same as up here for your least common denominator between 4 and 5, you do 4 times 5 is 20. So this side has an x minus 5. It needs an x plus 2. And you have to do that to the numerator and the denominator. And I add parentheses everywhere just to make sure you don't forget. This side has the x plus 2, so it needs the x minus 5. Now, so, and you can do this step all in once if you want to, but I'm going to do it separate. So we're left with x plus 2 times x plus 2 plus x minus 1 times x minus 5, because our denominators are the same, so we're just going to add the numerators all over our least common denominator of x minus 5 times x plus 2. Now don't cancel anything out or anything like that, because if you do, you're going back to your original problem. And again, you can't cancel because this is a plus, it's not a times, so you have to do each piece. You can't separate them, do them. The biggest mistake on these is people cross these out thinking of multiplication, but it's not, it's a plus. So what you need to do, you can leave your denominator in factored form, just leave it alone. And then you need to actually multiply out the numerator and then see if it'll factor. Most of the time they won't. Sometimes they will and you can cancel a factor, but most of the time they won't. But you need to at least check. So x times x is x squared plus 2x, or 4x if you want to go ahead and add it, plus another 2x plus 4, plus x times x is x squared minus 5x minus 1 times x is minus x, and then negative 1 times negative 5 is positive 5. All over that same denominator. So this is 4x. Instead of writing it all again, I'm just going to write it at the top of it. Minus 5x minus x is minus 6x. So combine like terms. I have x squared plus x squared is 2x squared. 4x plus the negative 6x, or 4x minus 6x, is minus 2x. And 4 plus 5 is 9. Over that same denominator. And then this is what you need to check to see if this factors. It won't. Probably the quickest way to check is if you do 2 times 9, you get 18. If you list your factors of 18, you've got 1 and 18, 2 and 9, 3 and 6, and that's all. So do any of these combinations add up to negative 2? No, you cannot make any of these give you a negative 2, so therefore it won't factor. So that's the quickest way to check. Like I said, generally these probably aren't going to factor. Sometimes they will, and like you might end up with an x minus 5 and you could cancel that to simplify, but most of the time they don't. So this is just your final answer. For the last two here, we have 3a plus 5, over a plus 4 times a minus 1 minus 2a over a minus 1. So again, you need to find your least common denominator. So you have an a plus 4 and an a minus 1 and then another a minus 1. So they already have an a minus 1, so they need to both have an a plus 4. So our least common denominator is a plus 4 times a minus 1. So you don't have to do anything to this one because it already has that. So over here we have to do a plus 4 on the top and the bottom. So you have to be careful when you have minuses. The biggest mistake on these two is the minus. You lose the minus. So we're going to have 3a plus 5 minus, and it's minus this whole piece here, 2a minus 1 times a plus 4. And if you want to put brackets even, just to make sure you remember it's minus all of that, once you multiply it out, that's fine. It's usually a good idea because, like I said, people drop the negative. So again, leave your denominator alone, but multiply out and see if you can simplify your numerator. So we would have 3a plus 5 minus, keep your bracket, multiply this out, 2a times a is 2a squared, 2a times 4 is 8a, minus a is 7a, and then negative 1 times 4 is minus 4. Over that same denominator. So if it's minus this whole piece, then that means all these signs switch. So if you want, you can do it with a different color and put plus. This is a minus, this is a minus, and that's a plus. So like I said, on the subtraction problems, usually that's where the mistake happens, is these brackets are gone and you only do minus 2a squared and leave these signs the same. But it's minus everything, so you have to switch all those. So to write it with the square first, there's only a negative 2a squared. There's no other a squared, so we've got negative 2a squared. 3a minus 7a or plus negative 7a, however you want to think about it, is minus 4a. And 5 plus 4 is 9, all divided by that same denominator. And again, you need to make sure this factors, make sure this doesn't factor, I should say. And the easiest way to check is multiply 2 times 9, your a times c, and see if factors add up to negative 4 or negative 2 times 9. So we just did that over here. So 18, none of those will give you a 4, so it will not factor. So for this last one, so this one actually doesn't have the factors already factored out, or the polynomials already factored out. So you have to factor it first. You could, if you wanted to, say x squared plus 9x plus 14 times x squared minus 4 is your common denominator. That would work, but it makes it more work because if you factor it, they might have a common factor that you then don't have to multiply by. So anytime your denominators are not factored, you want to factor them first. So x squared plus 9x plus 14 factors into x plus 7 times x plus 2 minus x squared minus 4 is the difference of squares, so it's x minus 2, x plus 2. So you have in the denominator x plus 7, x plus 2, x minus 2, and then another x plus 2. So both of these have an x plus 2, so you don't have to worry about that. They each, this one over here would need an x minus 2, and this one over here needs your x plus 7. So our least common denominator is x plus 7 times x minus 2 times x plus 2, or whatever order you want to write that in. So this one needs your x minus 2. And this one needs x plus 7. So it makes it easier because then all you have to do in your numerator is you're multiplying two binomials, which is much better than multiplying a binomial times a trinomial if you didn't factor it first. So always factor the denominator first and see before you get a common denominator. So we have x minus 2 times x plus 3 minus, again, if you want to go ahead and add that bracket so you don't forget to carry that negative, x minus 5 times x plus 7 all over that common denominator. So multiply the numerator out, leave your denominator alone, multiply the numerator out and simplify. So we've got x times x is x squared, plus 3x minus 2x is plus x, negative 2 times 3 is minus 6, minus, keep your bracket, x times x is still x squared, plus 7x minus 5x is plus 2x, negative 5 times 7 is negative 35. All over the denominator. And then again, if you want to write it again, that's fine, or if you want to switch signs, if you can do it in your head, that's fine too. If you switch to plus, this is a minus, this is a minus, and that's plus. So I've got x squared minus x squared, or x squared plus negative x squared, however you want to think about it. So those actually cancel. I've got x minus 2x, so that's a negative x. I've got negative 6 plus 35, which is plus 29, all over that denominator. And this is not down here, so you can't cancel anything, so that is just your final answer. So be careful on the negatives and make sure you factor out the denominators before you add or subtract to get the common denominator, because it makes it easier. And also for these, you're still assuming that the domain is anything that doesn't give the denominator 0. So you don't actually have to say that, but just operate under the assumption that the problem will work regardless of what, you're not going to plug anything to give you a denominator of 0, I should say.